When we see the sun shining in the sky, it is day, and when we don't, it's night. So the question is, why is the sun in the sky seen at some times and not at others? We see that the sun seems to move across the sky starting in the east in the morning, then moves toward the south at noon, and then finally toward the west as the day ends. How does this happen? Actually, the sun appears to move across the sky because the Earth rotates on its axis. Axis is an imaginary straight line passing through the North Pole, the center of the Earth, and the South Pole. It is tilted at an angle of 23.5 degrees. The movement of the Earth on its own axis is known as rotation. Let's see why we have days and nights. Let's assume this globe is our Earth and this lamp is the sun. Now, look closely. The light is shining only on one side. This is day. Now look at the other part and you can see it's dark. This is night. When the Earth rotates, day changes to night and night changes to day. That's how the rotation of the Earth causes day and night. Pretty cool.
How do stars form? Stars are like huge balls of fire that emit a tremendous amount of heat and light. Stars don't form in a few seconds, minutes, or hours. Star formation process is so slow that it can take millions of years. A star begins its life inside vast molecular clouds of dust and gas. These molecular clouds are also known as nebulae or dark nebulae. They mostly contain hydrogen and helium molecules along with some other particles. Normally, these molecular clouds are cold and stable. However, a nearby supernova explosion or galactic collision may send a shockwave or tremendous amount of energy through a molecular cloud. Now, in the molecular cloud, this energy causes a gravitational disturbance due to which it begins to collapse on itself under its own gravity, causing hydrogen and helium to clump together and thus increasing the mass in the center of the cloud. This increase in mass increases the gravitational pull, thus attracting even more molecules and particles from the surrounding. As more and more molecules and particles collapse or fall into the center of the cloud, the center begins to heat up. This heated center or heated core is known as a protostar. A protostar continues to pull more molecules and gets hotter and hotter until the temperature and pressure reach to such an extent that hydrogen nuclei begin to fuse with one another, producing helium and releasing heat, light, and radiation. This process is called nuclear fusion. When this happens, the inward force of gravity is exactly balanced by the outward force created by heat and radiation. These inward and outward forces maintain balance and thus, a star is born. What if the sun disappeared?
We would need a lot of flashlights.
No. The sun's enormous mass and gravitational power locks the planets in their orbits. If the sun disappeared, the Earth would fly off in a straight line into space. Earth would collapse into darkness only after 8 minutes, as sunlight takes about 8 minutes to reach Earth. Moon would disappear as it doesn't produce light of its own. Plants would die, as no sunlight means no photosynthesis. Within a week, Earth's temperature would drop below 0 degrees Fahrenheit, dropping to negative 100 degrees Fahrenheit within a year, making it impossible for us to survive. Ocean surfaces would freeze, however. Water in the interior would stay liquid, due to heat from the Earth's core. Only microorganisms who don't require photosynthesis would survive by converting coarse heat into the energy they need. Thus, without the sun, humans wouldn't exist. What if the moon disappeared?
the Great will start shining and take its place.
Oh, Firstly, our nights would definitely be darker. Due to this, night predators like owls would find it very difficult to hunt at night. But this would be great news for stargazers as there is no interference from moonlight. Secondly, as the moon's gravity is no longer there to hold the Earth, it would rotate faster and thus our days will be much shorter than 24 hours. Craters on Moon are a proof that it has protected Earth from thousands of asteroids and comets. This no longer will be the case. With the Moon missing, tides in our oceans will be much smaller as only sun will slightly influence them. Changing tides will also influence the global weather patterns. Finally, Moon's disappearance might tilt Earth's axis drastically, causing extreme changes in seasons and climate.